Now we are going to learn about Kirchhoff's law. The Kirchhoff's law is a very important law to calculate the equivalent resistance and the values of current in the different branches in the electrical circuit. So what is Kirchhoff's law? Kirchhoff's law, it has two statements. Number one, it is called junction rule. The second one is called loop rule, or it is also known as mesh rule. So what is the junction rule? The junction rule states that the algebraic sum of all the current entering at a junction is equals to the algebraic sum of the current leaving the junction. So what does the junction rule says that? The algebraic sum of the current meeting at a junction is zero. What does it mean? The first one says that the algebraic sum of the current entering at a junction is equals to the algebraic sum leaving the junction. Now, suppose that this is a junction where all the wires are meeting. So these are the current which are meeting at the junction. These are the leaving the junction. So I1 plus I2 plus I3, I1 plus I2 plus I3 is always equals to I4 plus I5. So what does it mean? It means that the total charge remains constant. That the charge entering will be equal to the charge leaving the junction. So it is based on the law of conservation of charge. Now the second rule is called as the loop rule or the mesh rule. The loop rule or the mesh rule says that the algebraic sum of the potential difference, the difference in potential in a closed loop is zero. So it says that the algebraic sum of the difference in potential in a closed loop is zero. Or in other words, we can say the algebraic sum of the product of the algebraic sum of the product of current and the resistances in the branch in a closed loop is always equals to the total EMF present in the loop. What is that? The algebraic sum of the product of current and resistances present in a loop, present in a closed loop is equals to the total EMF present in the loop. That is I1 R1 plus I2 R2, you can say plus I3 R3 equals to total EMF. Now this plus sign will depend upon the direction of the current. So in general we say that the clockwise is positive and the anti-clockwise is negative. So sometimes this plus can also be the minus. It depends upon the direction of the current flowing in the loop. Okay. So we will discuss this in a numerical. So therefore summation of I into R equals to total EMF. Right. Now let us understand the Kirchhoff's law. We are solving a numerical from the NCERT textbook, right? So the circuit is like this. Right? Now, let us solve the math. So, how to do this? We will take out the current from here. Let the current is I. Now, from this we will take the current I1. It is moving. Now the balance is moving from here. So this is I minus I1. Right? Now this I1, when it will go here, now here also the current is coming, let that current be I2. So the current always we take from the positive end. So the current is coming out from here also. Now this I1 plus I2 together will be traveling in this. So I1 plus I2 will be in this branch. Now when this I1 plus I2 will come here, then what will happen? Because we have already taken current I from here, so we will have to give back the current I. So what is the balance out here? The balance is I1 plus I2 minus I, right? And then I1 plus I2 minus I and I minus I1 will be coming here, so that we are getting back the I2, right? Now we will name it the loop. So let the loop are A, B, C, D, and let it be F. Now this is my loop 1, this is loop 2, and this is loop 3, closed loop. So for loop 1, for loop 1, what is the name of the loop 1? A, B, C, A. A, B, C, A. Now, the second rule says that the product of current and resistances. So, I1 into 4, I1 into 4 plus, because they are moving in the same direction, plus I1 plus I2 into 2 plus I into 1 equals to 10, because the 10 volt is given over here. Now, this is loop 2. Loop 2, for loop 2, what will be loop 2? So, if we are taking loop 2 like this, A, B, C, A, A, B, C, A. In this case, we are taking this as a positive. For example, if you take this positive, then this will become negative. So, this is I minus I1 into 4. This is coming from this way and it is opposite. So minus I1 plus I2 minus I into 2 plus I into 1 equals to 10. Equation 2. Now for loop 3, the third loop. In my third loop, you can see what is the expression. The expression is, what is the name of the loop? The name of the loop is FBDF. FBDF. So it is I1 plus I2 into 2 plus I1 plus I2 minus I into 2 equals to 5. So let us solve. How many I1 is there? 4 plus 2, 6. So 6 I1 plus 2 I2 plus I equals to 10. Equation 1. Now 4 I1 minus 4 I1 minus 2 I1. So minus 6 I1. And then how many I2? 2 I2 minus 2 I2. So minus 2 I2 and then 4I plus 2I, 6I plus 1 plus 7I equals to 10. Equation 2. Number 3, how many I? 2I1 plus 2I1. 4I1. How many I2? 2I2 plus 2I2, 4I2 minus 2I equals to 5, equation 3. Now let us solve from equation 1 and 2. From solving equation 1 and 2, equation 1 and 2. These two will cancel, so it is 8I equals to 20. So therefore, I equals to 20 by 8. So this will be 5 by 2, that is 2.5 ampere. So the current coming out from here is 2.5. And then we can solve the other equations also. We can find out what is the value of I1, what is the value of I2. Okay? Yeah.